Welcome everyone. This is chapter number 5b about modern CPUs or central processing units. I'm your instructor Dr. D. So let's see about processor architecture. It determines what software can run on the computer, and microprocessor or processor architecture also judge what other hardware components are supported to that architecture. It determines location of CPU parts, bit size, number of registers, pipelines. And main difference between CPUs is processor architecture. So Intel being leading manufacturer of processors, the first worldwide microprocessor launched was Intel 4004, IBM PC powered by Intel 8086, and the current processors include Centrino, Titanium, Pentium 4, Xeon, and so on. So let's have a look on evolution of processors. We have in 1971 the first microprocessor 4004, then 72 8008, that was 8-bit microprocessor. Intel 8080 was launched in 1974, then is 8085 in 1976, then 16-bit in 1978, 82 it was 16-bit 80286, then is 1985. Here we can see that is 32-bit chip. In 1989 it was Intel 860 processor. So in 1992 it was the first overdrive processors which allowed users certain upgradable PCs. Then it was advent of Pentium series 1993, 1995 32-bit, then 1998 Xeon, 1998 Celeron, 1998 we have strong ARM technology, 99 is Pentium 3, and year 2000 is P4 or Pentium 4. Then is 2001 server workstations, 2002 is Micron technology, 2003 Centrino, 2006 quad core, then is Core 2 quad processors in 2007. We have energy efficient chips, and then is visibility smart second generation, and then is a third generation. So this is just an overview of evolution of processors. We will be looking in detail in a while. AMD referred as advanced micro devices. So this was main competitor to Intel, originally produced budget products, and current products outperform Intel. Current processors of AMD include Sempron, Athlon FX64, and Athlon XP. Freescale, that is subsidiary of Motorola, co-developed by Apple G4 PowerPC, currently focuses on Linux market. IBM historically manufactured mainframes and partnered with Apple to develop G5. So comparing processors include speed of processor, size of cache, number of registers, bit size, speed of front side bus. Advanced processor topics include RISC or RISC processors, that is abbreviation of reduced instruction set computing. They include smaller instruction set, may process data faster, PowerPC and G5 are its example. So parallel processing means multiple processors in a system. They can work parallelly. And systematic multiple processing, they include number of processors in power of 2. Massively parallel processing, they include thousands of processors, and examples are mainframes and supercomputers. So extending the processor power, standard computer ports are used. For every peripheral device, a specific port was used. Although it has been standardized, most of the devices have standardized towards USB standard. However, still several places peripheral specific computer standard ports are used. They include mouse and keyboard ports, USB ports, parallel ports, network ports, modem, audio, video, serial, etc. So this is standard computer ports interface you can see here. This is for a desktop computer. Serial and parallel ports were used to connect printers or modems. Parallel ports move bits simultaneously. They were made up of 8 to 32 wires, and internal buses used are also parallel. So as compared to parallel ports, serial ports move one bit at a time, low data flow than parallel, and they require control wires. UART converts from serial to parallel. So this is the advice for converting serial to parallel. SCSI or SESI, small computer system interface. It supports dozens of devices. External devices are daisy chain, fast hard drives, and CD-ROMs. They use SCSI drives. So it's not end of the chapter. I would like to have an overlook on computer processor history. It's very interesting history we will see, so you can have a cup of tea or coffee. So this list includes release date and the major event performed in respect of computer history. So in 1823, Baron Jones Jacob discovered silicon. So silicon element, which today is the basic component of processors. In 1903, Tesla patented electrical logical circuits, also referred as logical gate, or switches. In 1947, John Bardeen and William Shockley invented the first transistor at Bell Labs, and they patented the first transistor in 1948. In 1956, the group of scientists were awarded Nobel Prize in Physics for their work on transistor. In 1958, ICs or integrated circuits were developed by Robert Noyce and Jack Kilby of TI. So Robert Noyce was a CEO of Intel. In 1960, IBM developed the first automatic mass production facility for transistors. So you see in 1960s, huge production of transistor has started. In 1965, Gordon Moore, also known by his law, that is Moore's law, he made his major observation about ICs or integrated circuits. In 1968, Intel Corporation was founded by Robert Noyce and Gordon Moore. AMD or Advanced Micro Devices was founded in 1969. In 1971, Ted Hawke first introduced microprocessor, namely Intel 4004. In 1972, Intel introduced 8008. In 1974, Intel improved the same processor and 8080 Intel 8080 became industry standard. Then in 1976, Intel introduced 8085. In 1978, Intel introduced 8086. In the next year, it was 8088. So in 1979, Motorola 68000 with 16 and 32-bit processor was released. In 1982, 80286 was introduced. 1985, 80386 was introduced. In 1987, Spark processor was first introduced by Sun. In 1988, Intel 80386 SX was introduced. Cyrix in 1989 first released their co-processors. In 1991, AMD introduced AM386 microprocessor family. In 1991, Intel introduced 486 SX chipset. And in 1992, Intel released 486 DX2. In 1993, Intel released Pentium processor. 1994, it was the second generation of Intel Pentium processor. In 1995, Cyrix released CX5X86 processor. The same year, Intel introduced Pentium Pro, and Cyrix released Media GX processor next year, 1996. So the same year, 1996, Intel announced availability of Pentium 150 MHz. You can see that different companies, the microprocessor companies, started competitive market here. So in the same year, 1996, AMD introduced K5. 1997, AMD released K6. 1997, Pentium 2 was introduced. 1998, AMD introduced K6 2 processor. In 1998, Intel released their first Xeon processor, the Pentium 2 Xeon 400. 1999, Intel released Celeron 366 MHz and 400 MHz. 1999, same year, AMD released K6 3 processors. 1999, Intel Pentium 3 500 MHz was released. The same year, AMD introduced Athlon processor. In the same year, Pentium 3 600 was launched. Again the same year, 533B and 600B MHz Pentium 3 was launched. In the same year, Coppermine series was also launched. So in year 2000, AMD released 800 MHz Athlon and Intel released Celeron 533. Then AMD first released Duron processor with 600 MHz to 1.8 GHz. The same year, Intel announced 1.3 GHz Pentium 3. 2001, Intel released 800 MHz Celeron processor. In the same year, Intel released 1.3 GHz Pentium 4. In 2001, AMD announced a brand new scheme, AMD Athlon XP processors. Next year, 2002, Intel released Celeron 1.3 with 100 MHz bus. 2003, Pentium M was introduced by Intel. In the same year, AMD released first single-core Optron. 2003, AMD released first Athlon 64 processor. In the same year, Sempron processor was released by AMD. 2005, AMD released first dual-core processor Athlon 64 X2 3800. 2006, AMD released Athlon 64 FX60. The same year, Intel released Core 2 Duo processor, and the same year, Intel released Core 2 Duo processor with Core 2 Duo processor E6300. Now I will only mention their numbers. And in the same year, Core 2 Duo processor T5500. 2007, Intel released Q6600. So it was 8M cache. And the same year, E4300 was released. And the same year, quad-core processor Q6700 was released by Intel. And the same year, E4400 was released. AMD same year released Athlon 64 X2 processor. And the same year, Intel released Core 2 Duo processor E4500, E4600. Phenom X4 processor was released by AMD in 2007. 2008, Intel released Core 2 quad processor Q9300 and Core 2 quad processor Q9450. 2008, Intel released E4700. 2008, AMD then first released Phenom X3. Intel released Intel Atom series, and 2008 E7200 was released. The same year, E7300 with 3M cache and 2.66 GHz was released. The same year, then Q8200, and the same year, E7400 processor was released, and the same year, it was Core i7 desktop version released. 2009, AMD then released Phenom 2X4. The same year, Athlon Neon processor was released, and then Intel released E7500. AMD released Phenom 2X3. 2009, Q8400 by Intel, and then E7600. Then AMD the same year released Athlon 2X2, that was dual core. 2009, AMD released Phenom 2X2 dual core. The same year, first Athlon 2X4. Then 2009, Intel, it was mobile processor i7. In the same year, i5 desktop processor. The same year, Athlon 2 triple core X3. Intel released Core 2 quad processor Q9500. Now 2010, Core i5 mobile processor was released, and then it was i650. The same year, it was i3540. In the same year, it was Core i3 mobile processors. The same year, AMD released Phenom 2. So you see that these developments are being made in the recent 2 decades. Now we come a little more closer. Now this is AMD series going on, A10. That is Athlon 2. The first Intel processor BGA1364 socket was released. So we just move ahead. Now in 2017, first Ryzen 7 processor was released by AMD. That is Ryzen 5. Then Intel released Core i9 desktop. In 2017, AMD released Ryzen 3. And the same year, Intel released first desktop processor with 12 cores. AMD then released 16 cores, 14 cores, 16 cores by Intel, and then 18 cores by Intel, In 2018, Intel released Core i9 mobile processor. In 2020, NVIDIA announced that it was acquiring ARM, and then the same year AMD announced it's buying Xilinx. So now we are in 2021. So I'm assigning you a little homework. Your home assignment is to search about latest microprocessors for 2021. So I hope you have gained a glimpse of history. So if you have any question, please do comment, and if you like the video and do subscribe. Thank you very much.